Is the first one a polynomial? What are my exponents? Really? What are my exponents on A? Yeah, the rock count. So it's 4, 3, 1, 0, technically. Are all of those whole numbers? Whole numbers are 0 and onward. Are all of those whole numbers? Yes. So that's a polynomial. Cool. Polynomials have whole number exponents, just so you know. B, polynomial or not? Why not? Because it's -1, right? And if this was a written response, you'd have to explain why. It's not a polynomial because the exponent is an integer and not a whole number, right? What about C? Is the root over the x or just the 5? Just the 5. So it's fine. Because this would be root 5, x to the what? X to the 1, and then this is x to the 0. Are my exponents whole numbers? Yeah, so this is a poly. What about this one? We have 3, that's good. We have 2, that's good. We have x to the 1, is that good? No, because it's not actually x to the 1, it's x to the -1. You'd bring it up. So, not. What about E? 5, 4, 3, x, and then this is x to the 0. Are all those? What about the x? Is x a whole number or is it an x? It's an x, right? It's an exponential. We're going to learn about this. This is an exponential. So this kicks it out. It's not a polynomial. Your exponents need to be whole numbers. Can't be variables, can't be negatives. Another one that makes not a polynomial, I'm going to show the difference between the two. So this one here is a polynomial, but one that looks like that isn't, is if I did this. If I actually had the square root over the x, that would be x to the half, right? Anything with a square root is just the exponent of half. And the reason why that is our index is a 2, and then we have our little exponents of 1 on it. So I could rewrite this as 5 to the half. Thanks, board. 5 to the half, x to the half, plus 3x to the 0. And this is not a whole number, so that wouldn't be a polynomial. So if your square root is over the variable, it's not a polynomial. If your square root's over the number, square root of 5 is just a decimal. That's totally fine. Okay? This one we talked about already. Okay. Here's a graph. I want the equation. I don't know if you can see this. This is -3. This is 3. This is 2. This is 5. I want the equation. Remember, you do y equals a and then your factors, and then you solve for a every single time. It doesn't matter what form I ask for it. That's the only way you get an equation of a polynomial. Will there be a graph that you have to determine equation on the test? Yes. If you're like, I wonder if she's going, I told you I'm going to. It's a curriculum outcome. I'm not going to bypass a curriculum outcome. There will be an outcome where I make you find the equation. And I fear that people don't trust me when I say that. There will be. It will be. There will be one. Okay? I promise you, at least one will be on there. Okay? Every single time. Now, if I gave you the equation like this, I want it in the form, I hate this book, y equals ax cubed plus bx squared plus cx plus d. And I said a and d. Something about a and d. Say I asked you anything about that. You can't put it into that form. I've said that over and over and over again. There's no way you can put it into that form. You can never start in that form. You will never get it into that form. That form is not going to happen right off the bat. There will be no way that you can put it into there. We agree? It cannot happen. The only way you can do these is every single time y equals a, factors, factors, factors. Solve for a every single time. There's no case where you can go right to that. And if you're like, challenge accepted, go ahead. There is no case where that can happen. Okay? So we will have to do y equals a, x minus 3, x plus 3, sorry, x minus 2, x minus 5. The other place where the errors happen on the test is when there's points of tangency at your x-intercept. You have to remember to square it because you have a multiplicity of 2, right? If there's a point of inflection on the graph, that curvy snake thing that goes through it, that would mean a multiplicity of 3 at that 0, and I would have to cube it, correct? Does this graph have any of that happening? No, straight line, straight line, straight line. So they would all be to 1s, right? But on the test, do you see how it could be an easy way to forget to put the squared or the cubed? Yeah, you're going to get the wrong answer. Okay? Then I take a point, often bolded. It's either bolded, it will be bolded. They will have a bolded point. You use that to get your x and your y. So, to solve for your a. So you get negative 3 equals a, 0 plus 3, 0 minus 2, 0 minus 5. These should be, I promise you, these should be the easy question. This should be an easy question on the test. It should be your easy question. There's no trickery. They're all the exact same. And they sometimes ask for the a and the d at the end. So I get negative 3 equals a, 3 times negative 2 times negative 5. So negative 3 equals negative 30, positive 30, 38, divided by 30. And a equals negative 1 over 10. And then I'm not done because that isn't the equation. That is my vertical, what?
It has to be a fraction.
Yes. Because they'll often ask for it in fraction form, right?
Yes.
Now, if you don't, like there was that question on the, I'm getting ahead of myself. I'm just going to write out the equation. So we're going to have y equals negative 1 over 10, x plus 3, x minus 2, x minus 5. Now this is perfect if they ask for it in factor form, right? I have never seen them ask for it expanded on a diploma, but that doesn't mean they can't, okay? They could ask for it in the form ax cubed plus bx squared plus cx plus d. If they do, you still have to find this form and then expand. That's the only way you can get the whole thing. But they rarely ask for that. They'll often just ask for the a or the d because they're easy to find. Your a is your leading coefficient, right? Now, in the actual handed, I had like y equals negative 1 over a, and then they wanted the value of a. Well, the value of a then would correlate directly with just the 10, right? Now, you want to do your a. So people will tell me, well, it's negative 1 over 10. I can't even fill negative into my numeric response box. It's a garbage question. No, that is your a, not the a they asked for. They asked for it in the form y equals negative 1 over a, and then factor, factor, factor. So their a is actually what's sitting below the negative 1, which is 10. Okay? So you have to not like fall to your a. Well, I found an a, and it's negative 1 over 10. Cool. You found an a. That was your choice. Their a is the negative 1 and then over a. Majority of you got it right. So I was very happy with you that you put 15. Most people will give me the answer to 1 over 15, which is not right. Now, if I want the leading coefficient, remember what I tell you to do? I told you to write them all out. So if they ask me for a in this form, do I have to expand the whole thing out? No. Remember we said we just have to take that leading coefficient, that vertical stretch factor, that A we found, and distribute it into my x's. So I told you that if I had an x plus 3 squared, I would write it out twice, right? I would still write it out twice so I don't mess up my expanding. So if they wanted the A in this form, I would go -1 times x times x times x, and I would actually get -1/10 x cubed. So my A would be -1/10 if they asked it this way, where they wanted the A that was in front. Very different way of asking questions, right? What if they asked me for the D? What is the D? Just fancy way of saying this is the constant, but what is my constant when it's in an equation with no brackets? What is this? I know you know it.
Y-intercept.
Yeah. It's the y-intercept. When I hear y-intercept in a hallway, in a store, I should just walk up to you guys wherever you work and just say the word and see if you say it. Randomly find you on the street. Y-intercept, and you should scream x = 0, and then all your friends would think you were a weirdo. But that's fine, unless they were the friends here that understood it. But if I scream y-intercept to you, you should immediately scream back at me x = 0. Those should be like, it should be like our thing, like x-intercept, and you scream y = 0, and I scream y-intercept, and you scream x = 0. Like it should be like a common bond we have. Actually, it should be for every math teacher in any subject ever, because that is what you should think when you hear y-intercept. Okay? So when I see the D, I think y-intercept. When I think y-intercept, I think x = 0. So I would have -1/10, 0 plus 3, 0 minus 2, 0 minus 5. And then I can find the y-intercept, which is just the D. Right? I don't have to expand the whole thing out. I'm looking for the y-intercept, right? A is my leading coefficient. I can find it quickly by multiplying it by all the x's. The y-intercept, I just need x = 0, right? So I would get -1/10. And then this is the same thing as I had before, -6 times -5, which is 30, over 1. And so I would get -30/10, which is -3. So my D would equal -3 without me having to find the whole thing, right? Now, if they ask for the B or the C, is there a fast way to find those? No, you have to expand the whole thing and collect like terms. There is no other option, okay? But the leading coefficient you can find quickly. The D you can find quickish. It's better than expanding the whole thing, right? But if they ask for the B and the C, there is no quickish way. You have to expand it. All right. Good talk. Same thing. Go. I want the equation. I want the equation in factored form. And then once you found that, I want the equation. What is this? Linear, quadratic, cubic, quartic, quintic? Degree 1, 2, 3, 4. We know it's even because what? The arrows are both down. And we know it's not a quadratic, so it's a degree 4. We only have 2 even options. Remember, at degree 5, I have to stop. This is degree 4. Yeah.
What's the x-intercept on the list?
This one is -3. This is 1. That is 5. This passes through 0, 5. It doesn't, but we're going to say it does. It's going to be your bolded point. 1 sec. All right, so we would get y equals a. Now, if we stated the x-intercepts, this is very different. If we state the x-intercepts, if it asks us for the zeros of this function, okay? If it just asked for the zeros, which it did not, but say it asked for the zeros, I would say x equals -3. I would say x equals 1. I would say x equals 5. How do I, that would to me would be a cubic function. Right, I have 3 x-intercepts, I guess, probably a cubic function. What am I forgetting? Yeah. Multiplicity, too. We have to state it. So in a 0 or an x-intercept or a root, you have to state it this way. For a graph, you don't have to state it because in a graph, you're showing it as a square, right? You're showing it as a square and it's on the factor. So as x-intercepts, you explain it as multiplicity 2. On a graph, as an equation, we would just square it, right? If it went through to an inflection, we cube it, or multiplicity 3 as a 0. So we're going to get y equals a, x plus 3, x minus 1, x minus 5 squared, because there's 2 of them. Board. Okay, then I plug in my 5 and my 0. So I get 5 equals a, 0 plus 3, 0 minus 1, 0 minus 5 squared. 5 equals a, this would be 25 times 3, 75 times negative 1 is negative 75. By negative 75. Go away. And a is going to equal negative 15. 1 over negative 15. Should seem familiar from your hand in. Okay. So that would be a. Come on, let's grab a minute. Okay, that's a y. Y equals negative 1. Oh, it's because I used the 2 together. I see how I did that. That was garbage. Don't do that on test. All right. Okay. So if in factor form, we'd be done. But if it asks for the a of this, or the d, or sorry, the e in this case, my a ends up being negative 1 over 15. It's true because all of my roots, all of my zeros were whole numbers or integers. So I have x plus 3, x minus 1, x minus 5, x minus 5, and I write them all out separately. This has a 1, a 1, a 1, a 1. So if I go negative 1 over 15 times 1 times 1 times 1 times 1, I still get negative 1 over 15, x to the 4, right? We're going to do an example where we don't just get the same a value. So in this case, a, this a sitting in front of the x squared, or x4, a equals negative 1 over 15. And they are the exact same. And some people will say, well, they're always the exact same. No. If I get an x-intercept that's actually a fraction, I'm going to get a factor. Say my x-intercept is x equals a half. Well, as a factor, I'd bring that up. I'd get 2x equals 1. Subtract 1, I get 2x minus 1. So my factor would actually be 2x minus 1. So now I would be multiplying my negative 1 over 15 times 2 times 1 times 1 times 1. So it'll change it. We've just had integer ones. We'll do one where we don't. Now if I want my e is just my y-intercept. My y-intercept means x equals 0. So I go y equals negative 1 over 15, 0 plus 3 times 0 minus 1 times 0 minus 5 times 0 minus 5. And so I get 25 times 3 times negative 75. So I get y equals negative 1 over 15 times negative 75 over 1. And what do you get? What's 75 divided by 15? So your e would equal 5. Because you get the y-intercept. Okay, what if I give you a question like this? Do I have to give you the y-intercept, or could I give you any other point? I can give you any point but the x-intercepts, right? I have to give you an alternate point. I'm just bolding this one because I'm late. I want the equation of this. What is it? Degree 1, 2, 3, 4, or 5? It's a degree 5. At minimum, it has to be a degree 5. Because how many x-intercepts are at negative 3? And how many are there? 4. 4, 5, right? So 3, 2, 4, 5. Got it. Yeah. I agree. I see where you're going with that. So there are a minimum of 5 x-intercepts on this. So it has to be at least degree 5 because you can't get more x-intercepts than the degree. Like you can't say, oh, it's a degree 3. No, there's already 3. That's 2. It has to be degree 5 minimum. Okay? So I want the equation in factored form, and then I want A and F. Do I have to ask for factored form if I want it in this form? No. Do you still have to find it in factored form? Yeah, you have no other option. Okay, let's look up here again because this is where people are going to go awry because I gave you a fraction as a root. Okay? So I know that my roots are x equals negative 3 what? Multiplicity 3. Because they'd ask for an equation in that form, so it has to be 3. And then x equals 7 over 2, multiplicity what? Do you want to see what I see on a test every time? X plus 3 is one of the factors, and then x minus 7 over 2. This will never work. This will be not ever an answer. This will never be an option. You have to remember to do 2 steps to work it back. I would bet that 95% of you have x minus 7 over 2 on your page right now. So, it is x equals 7 over 2. That is not what the factor was. What was the factor? Bring the 2 up. Bring the 2 up. If you remember to multiply by 2, most people will get this right. So you bring the 2 up and we get 2x equals 7, and then what do? Subtract 7. So yes, this is true about the zeros or roots or x-intercepts. But you have to remember when you work your factors back, this one is x plus 3. Why is it x plus 3? Because you had x equals negative 3 and you added the 3 back. Right? Same thing here. If you have x equals 7 over 2, you have to multiply the 2 up and subtract the 7. If you're someone who knows you're not going to do that, you need to write a note to yourself. I don't care if you put it as a note in your phone that reminds you at 9 o'clock tonight. I don't care. But you need to be reminded of it, because if you did it right now, you wrote x minus 7 halves. If you did that as your factor, you will do that in 2 days from now. And you might be like, no, I won't. Yes, you will. I see it every single time. The way to stop it is to leave yourself little reminders. X equals 7 over 2. Okay, that's 2x minus 7. X equals 7 over 2. Okay, that's 2x minus 7. Remind yourself every 5 hours. It's literally, you got to cut it off in the next 2 days, right? To not do that. If you don't remind yourself of that from this point till Wednesday, you will write x minus 7 over 2. And I'll just do this. Hang my head. That's all I'm going to do. Because I know it'll happen. If you're like, well, how do you know? 17 years of teaching. I know. Right? At least 3 times a year teaching 30-1. It's a lot. You multiply that up from 2012, which the new curriculum came out. We're at 36. Okay? I know what you will make a mistake doing. Trust me. I wish I didn't, but I do. This is where it will happen. All right. So factored form. Y equals a x plus 3 squared, and then 2x minus 7 cubed. This is also where the errors lie. If you're writing out roots, how do we know that there's more than one? You write multiplicity, correct? If you have factors, how do you know there's more than one? You square it or cube it. I get people mishmashing the two. Yeah.
Aren't they supposed to be switched?
Yeah. Little tiny eraser. So I get people when I see their roots. Do it in different colors. You can see I screwed up. This is the 3, this is the 2. Okay. I get people stating their roots as squared. They'll say x equals 7 over 2, and then they write it out and then square it or something. It's the strangest thing. That's not how you show a root. It's x equals 7 over 2, multiplicity 2. Okay? Factor, square, cube. All right. So then we plug in 0 and negative 10. Negative 10 equals a 0 plus 3 cubed, and then 2 times 0 minus 7 squared. Negative 10 equals a 27 times 49. And then negative 10 equals, yeah, some people will go 3 times 3 instead of 3 cubed. 27 times 49 is 1323a. This is as low as it goes. 1,323. So we get y equals negative 10 over 1,323, x plus 3 cubed. Now, should you panic when you see something like that? No, you have a graphing calculator that can see if you get that. You have a graphing calculator that you literally type the equation into your calculator, and you change your window to whatever my window is, which is not accurate because I drew it with my hands, guys. And you press graph. And then you check the max and the mins, and they're the same. And you're like, oh, I'm a rocket scientist. These match, and I am so smart. You don't go panic mode because you can check equations to graphs. You have the graph in front of you. You type the equation in your calculator. You press graph. They match or they don't match. Literally, you should walk away knowing, like, you should write an apology letter on here after if you aren't getting it right, because you should know you didn't get it right. You should be like, Mrs. Lepp, I am wrong. My graph and my equation do not match. I at least know that. Be kind. And then, like, heart. Like, love you. You know, like, you should know if you're totally out to lunch, because they shouldn't match. Right? I hope you can fix it, but if you can't, you should at least know you're wrong. All right. Now, my a in this case is not going to be negative 10 over 323. This a is not going to be negative 10 over 323, because I'm going to get negative 10 over 1,323, and then I'm going to get 1x plus 3 times 1x plus 3 times 1x plus 3 times 2x minus 7 times 2x minus 7. Okay? It's going to be this times 1x times 1x times 1x times 2x times 2x. What if you wrote it as x minus 7 halves? You don't have the 2's. Your a is wrong. Okay? So, times 4. I'm going to get negative 40 over 1,323 to the 5. So this is my a. Do you see when your a might not always be the same between the two? It's when you have roots that are not whole numbers or integers, that are fractions, because you're going to get that coefficient in front. Okay? And do you see how I expanded out so that you don't just multiply by 2, but you also multiply by 2 and 2, so 4? That's why I expand the factors out. Now, if I want f, now some people will go to their calculator and find it. Cool. You can do that if it's a multiple choice numeric response. But if it says determine a and f algebraically, you have to show the work. Okay? So we get y equals negative 10 over 1,323. 0 plus 3, 0 plus 3, 0 plus 3, and technically 2 times 0 minus 7, 2 times 0 minus 7. So we're technically multiplying this fraction by 3, 3, 3, negative 7, negative 7 to get our e. Oh, that's a lie. To get our f. Make sure you put fractions in brackets or use the fraction button. And I get negative 10. Screw that f. This is going downhill. F equals. Because f is my constant. My constant with no brackets is just my y intercept. And some people will say, how did you get that? I multiplied with my calculator this fraction times 3 times 3 times 3 times negative 7 times negative 7. Because these will just become zeros. Yeah. If it asks you to solve algebraically, you have to show algebra. Yeah. If it's a multiple choice or numeric response, once you get your equation, you could go to your calculator and my y-intercept, and I would have no difference. Yeah. It's only if it's written response. Okay? Did we do this one already? Was it on your hand and I can't remember? Yeah. I think so. Okay. Okay, I want you to factor this and then solve it. What do you suppose might happen on the test? I'm going to make you factor and solve. But what do you suppose I'm going to do to make it a little more difficile? No rocket counting. I'm probably going to make it so you have to put a placeholder. Right? So it'll go like, this one goes 4, 3, 2, 1, blast off. Cool. I might go 4, 3, 1, blast off, and you're missing the 2. What do you have to do if you're missing the 2? Put a 0. You just need to remember to rocket count. And what are my possible factors? What are they based off of, remember? Yeah, this. The factors of the constant. So it'd be plus or minus 1, plus or minus 3, plus or minus 9. So what if I gave you a multiple choice and I said, which of these are possible factors? And my answer is this. Oh gosh. Going downhill is faster. What if I said, which of the following is a possible factor? A, B, C, or D? Possible factor. B. Now, what if none of them are actually factors? I don't care. But I do know that 4, 7, and 5 can't be. So 3 is the only one that's a possible factor. So you have to watch the word possible. People will call me over all mad. And they're like, I plugged it in and none of them gave me a remainder of 0. And I'm like, cool. It says possible. And then I walk away and you're mad at me. But that is what I'm going to do to you. I say, cool. It says possible. Okay? So factor it out. What is my first? Oh gosh. What is my first one? X equals what? What'd you get? Negative 3. Rocket count 4, 3, 2, 1, 0. So guess what? There's going to be 2 questions on the test for sure that are going to do this. One, I'm not going to let you rocket count, so if you don't check, the placeholder's going to be garbage. You're going to call me over, say it doesn't get you a remainder of 0, and ask me why. And I'm going to say, can't tell you. I'm going to walk away. Rocket counting. 2, the other thing I'm going to make you do is solve something that doesn't work out perfectly, and you have to use the quadratic formula. Remember how we did those ones? When you get it down to your trinomial at the bottom, and you can't factor it, where does it have to go? Into the quadratic formula. Okay? There will be one of those. If you're like, nah, she won't. She's me. I know. I will. Okay? She's me. I make a test. It will have that. It's going to happen. Okay? So we have 2, 3, negative 17, negative 27, negative 9. What scares me is when I give a plain old factoring question and it's left blank on a test and people say sorry. You're like, that happens every year. Every single semester I have a sorry written there. Like you didn't know it was coming. It's a fact, like this is a blatant obvious question that's going to appear. So sorry, I'm just like, what? How'd you even get through the unit? Okay. So we get negative 6 plus negative 3, 9, add it. Negative 8, multiply 24, add it. Negative 3, multiply 9. Be excited because there's a 0. If something says is a factor on the test, what is that a fancy way of saying? What is 0? The remainder is 0. They're not going to say the remainder is 0. They're not going to say this. They're going to say this. They're going to say, is this a factor? They'll ask you, is x plus 4 a factor? Or they'll tell you x plus 4 is a factor, indirectly telling you the remainder is 0. Okay? You need to know that. And here I get 2x cubed minus 3x squared minus 8x minus 3, and then I have to factor again. What can I use? X equals what? 3 again, 3? Okay, 3 times 2 is 6, add it 3, 3 times 3 is 9, add it 1, 3 times 3 is, 3 times 1 is 3, add it 0, I'm happy. What was I just saying? There, you're going to end up with a trinomial. This is a trinomial, a quadratic, that you won't be able to factor. Don't call me over and be like, Mrs. Lepp, I can't factor it. I'll be like, cool, true statement, and then I'll walk away. Because you need to know that if you can't factor it, you put it into the very top left-hand side of your formula sheet, where there's a quadratic formula. You will get one where you have to do this. If you don't get one where you have to do this, be sus. Be sus. I really want to word sus. All right. So we have, oh my gosh, this is also something that was happening. What multiplies to give me 2 and adds to give me 3? 2 and 1. I was getting this. I wanted to cry. That is not a decomp question. I mean, that is not a product sum. It's a decomp. And we have a 2 sitting here. Do not give me that. Plus, your calculator shows that those are not the other 2. Like, it's a dead giveaway. Okay? Do not do that. Decomp. So it's 2 and 1, true statement, but you have to do decomp. 2x squared plus 2x plus 1x plus 1. Group. Take out a 2x. X plus 1. Take out a plus 1. X plus 1. We get 2x plus 1. X plus 1. Then my factors. So if I ask you for the factors are, do not forget about these. Those are my roots, but anyways, x plus 3, x minus 3. I usually write those down at first, right away when I get them. So x plus 3, x minus 3, 2x plus 1, x plus 1. Those are my factors. If I ask you to solve, wow, this is not working out well for me. I'm writing too fast. X equals plus or minus 3, negative a half, and negative 1. That is solve. What if I ask you to solve or factor and you do both, you box both? I'm like, I see what you're doing here. You have no clue. And then I take marks off because you don't know if it's factoring or solving. What happens if this? So pay attention. This is my synthetic division. Ready? I get x equals 2. I get a 0. I don't need the rest. I'm just going to explain. Then I get an x equals 3, and I get a 0. Cool. And then at the bottom here, I get 2x squared minus 3x minus 3. And I ask you to factor. Paying attention. Paying attention. I ask you to factor. It's very different if I ask you to factor or to solve. I ask you to factor. What are my factors? X minus 2, x minus 3. Can we check our factors? Yeah, they should give us back the same graph as the equation. They're the same. One's factored form, one's just standard form. Okay? Can I factor this? What multiplies to give me negative 6 and adds to give me negative 3? No, I made it specifically that you can't. I didn't even give you a real polynomial. I just gave you parts. You cannot factor that. So do I go to the quadratic formula when it asks me to factor? When it asks me to factor? No. This is a quadratic factor. These are the best questions ever when they're a factoring question because you can't factor it, so that is the factor. And you're done. Okay? Linear factor, quadratic factor. You can't factor it, you can't keep going. If I ask you to solve, however, it would be x equals 2, 3, and then what would I have to do to solve that? Times with quadratic formula. Quadratic formula. So if I ask you to factor, you go no further. Those are factors. When the moment you start putting it into the quadratic formula, guys, this is called solving. Because you're solving for x equals. You see the formula has an x equals on it. You are solving. So you don't do that in factors. So this would be your a, b, c. I get negative and negative 3, so plus 3, square root, negative 3 squared minus 4 times 2 times negative 3, all over 2 times 2. So I get 3 plus or minus 9, 20, this 12, 24. 9 and 24 is 33. It'll stay that way. What if I can reduce my radical? Do I have to? Yeah.
The spirit
This is an
of
exact
what
value.
This is Miranda's room.